Hello everyone, let's solve some Leetcode today. So today we have this Leetcode 53 problem, maximum subarray. The problem says that given an integer array nums, find the subarray with the largest sum and then return its sum. Basically we will have a nums integer array and we will have to figure out a subarray. The subarray should have the maximum sum among all the subarrays of this integer array. So basically what is a subarray, right? Suppose I have this array 1, 2, 3, 4. So subarray is basically a contiguous subsequence of the array. So it's a full array, right? The full array itself is a subarray of this array. So 1, 2, 3, and 4 is a subarray. Now single elements are also subarrays. So 1, okay, 2 is also a subarray. Similarly 3 and 4. This is a subarray. Then 1 and 2, they both together make a subarray. So 1 comma 2 is a subarray. 1 comma 2 comma 3 is a subarray, and so on. So now one thing to notice is that every time we are taking a subarray, the elements are continuous. They do not break in the middle. For example, 1 comma 3 is not a subarray. Not a subarray. It is a subsequence, but it's not a subarray. Similarly, 1 comma 3 comma 4 is also not a subarray because we have broken, okay, we have broken the continuity from 1 to 3. So the continuity from 3 to 4 does not matter anymore. So this is also not a subarray. So the question is basically saying that with all these subarrays, all the possible subarrays from this particular array, we have to figure out a subarray where the sum of its elements is maximum. For example, the sum of the element of this subarray is 10. Then for this, since it's a single element, it's simply 1. For this, the sum is 2. For this, 3. Then for this, it is 4. Then for this subarray, the sum is 3. For this subarray, the sum is 3 plus 2 is 6, right? So maximum we found till now is 10. So we have to return 10, okay? Of course, there will be more subarrays, but their sum will not be equal to 10. So maximum is what we have to return. So we return the 10. This is what the question is basically saying. So here we can see the example. We have an example array. The output is 6 because we say that the subarray 4, -1, 2, and 1 have the largest sum. So now let us try to solve it. First of all, we will have a brute force, then we will have a slightly optimal solution, or you can say better, and then we will actually have an optimal solution. So what is a brute force? Brute force means, I would say, if I can just figure out every single possible subarray and count its sum, and then compare it with the maximum, I will have the maximum, right? So first I will have to figure out every single subarray and its sum. So how do we iterate over every single subarray? Well, if you see here, we have 2, okay, 2 itself is a subarray. Then we have 2 comma 1 itself is a subarray, right? Similarly, we have 2 to 3, 2, 1, 3, 2, 1 minus 3, then 2, 1 minus 3, 4, then 2, 1, 4 minus 1, then 12, again till 2, and then so on, right? Till from here to here till here, right? So for 2 we can make 1, 2, 3, 4, 5, 6, 7, 8. So we can make 8 sub arrays for 2 itself. Similarly, if we go from 1, we can make the arrays or sub arrays like this. We have 1, then we have 1 to minus 3, then we have 1 minus 3 4, then we have 1 minus 3 4 minus 1, and similarly we can keep going. Okay, then similarly for this also minus 3 also we will have this, then this, then this, then this, then this, and it will keep on going. So basically what we are doing is we are taking one element and then we keep on adding into this array next elements, okay, all the next elements. So what we can say is that we have to iterate over each and every element in this array first. So okay, for int I is equals to 0, I less than n, and I plus plus. So this upper loop is actually going through each and every element of this array, okay. Now for this element we have I is equal to 0. This is the first element that we will take in the loop. We have to iterate over each and every element in the array to form a subarray, right? Then we will actually have again another for loop, that is int j is equals to I. Now j will start from I, because if I is this, if I is at 1, we will not take 1 and minus 2, because we have already taken 2 minus 2 comma 1. So minus 2 comma 1 is basically same as 1 comma minus 2. These two are basically same subarray. So we will not, retry this thing. We don't retry it, right? So we will only take elements coming after the I. So we will take I and then all the elements remaining. So that's why we are starting I until j is equals to I. Then j will go till end of the list. So n and j plus plus. Okay, this is a loop. So now at this point, suppose that I is at 1, okay, and at some point in the loop j is at 4, okay, j plus plus, that's what we are doing here, right? So while this I is fixed, the j will keep on moving, next, next, next. So j reaches 4 and 1 is, and I is at 1. So 1 to 4 is a subarray, right? And we have to calculate its sum, correct? So we have to again iterate from I to j to calculate its sum, because we have to iterate. So for int k is equals to I. So from I to j, we have to iterate k plus plus. Here we will actually start calculating sum. We will have a sum variable here. So here we will need a sum variable, int sum is equals to 0. And then here we will start in this inner for loop, sum is equals to nums of k. Sum plus is equals to, okay, we will keep on adding it every time. So this will keep on adding nums k in the sum until we are reaching from I to j. And so we will have the sum of this particular sub array as in our example from 1 to 4, right? Similarly, the same thing will happen for 2 to 4, 1 to 5, all these arrays. So once we have figured out this sum here, we will go on the outer loop, that is this loop, and we will compare. If the current maximum, okay, is greater than the current sum, then we can say that max is equals to sum, right? If it is not, the maximum stays the same, and at the end we can simply return max, and that will be our answer. Now this is basically kind of a brute force solution. Of course, the time complexity is what? Order of n cube. So the time complexity is order of n cube. Not exactly n cube, because the inner loop is running from I to n. So inner loop is not running every time from the first element, it is running from the current I element. So not exactly n cube, and this also is not running exactly n cube n times. So not exactly n cube, but still very close to n cube. The interviewer will definitely say that, okay, it's a n cube problem, the time complexity is n cube, try to make it a bit optimal, right? So what we can do is we can try to optimize this thing a little bit. So in terms of optimization, what we can try to do is we can try to reduce or eliminate this internal for loop that is actually calculating the sum. Try to do that, because that is the first thing that we see, which is increasing the time complexity. So from n cube to n square, we need to remove some kind of for loop, right? So we can try to remove this one. So how do we do that, right? We actually try to observe, okay, how are we actually calculating the sum? So what we are doing is that at one point when I is at this place or and j is at this place, what we are doing is we are again running a loop from this to this to calculate the sum, right? But let's try to see if we can actually optimize it, okay? Suppose that we are at I is equals to 0 and j is equals to 0, that is at minus 2 element. Now, if we want to calculate the sum, we can say sum is equals to minus 2 till now, right? Now j moves, j comes here, okay, j's value becomes 1, right? So we can say sum is equals to sum plus nums j, correct? So just think about it. The sum of this subarray was 2. The sum of this subarray was simply 2 minus 2 plus 1, right? So our sum till now becomes minus 1, right? The sum of this bigger subarray is simply minus 1, right? Now if I actually try to go even bigger, okay, we try to include this bigger subarray, the j comes here, okay, So what I can do is sum is equals to again plus equals to nums j, okay, or sum is equals to sum plus nums j, which is -1 plus -3, right, is equals to -4, correct? So the sum of this bigger is -4. Now the same thing can be actually done for any I, okay, and any j. Right now the I is at 0, but we can do the same for this one also. If I is at 1, what we can do is the sum of this is 1. The sum of 1 comma 3 will simply be 1 plus -3. The sum of 1 comma 3 minus 3 comma 4 will be sum of this 1 minus 3 4, right? Similarly, we can do it for any I index. So what we are doing is that we can simply keep on adding the next element of j into the current sum, and if the current sum that we got is greater than maximum, suppose that we got the sum 2, okay, we got the sum 2 and then we check. So if the current sum is greater than the maximum sum till now found, then the maximum sum will simply update, and this step, okay, this step will be performed after each and every sum. So what our loop will become is like this. We will have a for loop that is running from I is equals to 0, then I less than n, that is the number of elements in the array, then I plus plus, first loop. Then second will be for j is equals to I, okay, j less than n, j plus plus. Now here what we can do is we can actually start computing sum. So we will have an int sum is equals to 0, okay, and somewhere here we will have int max, okay, we will have this variable. Now what we will do is we will start doing this sum is equals to sum plus nums j, simple, right? And then we will here actually try to compare, okay, so max. So if sum at any point becomes greater than max, it will be replaced in the global max variable, okay, and then this loop closes, start from there, okay, and this outer loop also closes. So we have eliminated successfully one loop from our solution. So currently this solution is actually time complexity is order of n square, because we are only running two loops, okay, simple as that. So this is a pretty optimal solution, but the interviewer will still say that, oh man, like it's order of n square, right? Can you try to make it a bit better? Can you really make it a bit better, like order of n, like linear, right? And here the question comes that if we try to make it order of n, then how are we going to iterate through entire subarrays, all the possible subarrays, right? That becomes an issue, right? Because if we want to iterate over entire number of subarrays, okay, we will need at least two loops. There is no other way around it, which means that we need to shift our line of thinking a little bit. We cannot think that we need to actually iterate over all the subarrays to find the sum. We cannot think that anymore. How do we shift our thinking? Well, we will actually have to go back to the array and make some more observation. So here we have this array. Now understand that our goal is not to find subarrays, okay? In the question, there is nowhere written that you have to find all the subarrays or something like that. All you have to do is figure out the sum. Remember the goal always. Your goal is to find the sum. So how are you going to find the sum without actually going through each and every subarray? That is the question. So here what you have to do is you have to start observing some kind of patterns in the question, right? So you will have to actually think, I have a sum variable, I take -2, okay, and I simply say that, okay, sum is equals to -2. Now, if I take 1, we will have to iterate one time, right? So, pointer goes to 1. What will happen? Sum is equals to sum plus 1, right, is equals to -2 plus 1 is equals to what? -1. We will again have to do the same for -3. So, the sum is equals to like -1 plus -3 is equals to -4. Again, the sum for this 4, we will have to do -4 plus 4 is equals to 0, right? So what we are saying is that as long as we have a negative number as the sum, no matter what we do next, this negative number is going to try to decrease the total sum. The total sum will be decreased because of this negative number eventually. Just like we can see that the total sum simply decreased because -1 is greater than -4. Okay, remember -1 is greater than -4. Okay, so the total sum decreased eventually, but we have to make the maximum of it. And also you can say that -4 plus 4 simply returned into 0. We could, like, I mean, 4 is much better sub-array. Single 4 is than this entire array, right? I would rather take single 4 than this entire array because the sum is 0 at this point, right? What I can say is that, each time I get sum less than 0, I will simply reset the sum. Simply reset the sum. Why? Because a negative sum will eventually simply keep on decreasing the maximum sum, right? The maximum possible sum. It will just try to decrease it, right? So what we need is a positive sum. So here I have pasted it again, and now if we really look at it, till here we will have a negative sum. Okay, so for this we will have negative sum, then this, till here we have negative sum. So here we will simply say sum is equals to 0 for all these points. Okay, now once we reach here, we see 4, right? So we see 4, we say sum is equals to 4. Now we do not reset it because it's a positive sum, because we know that 4 will only try to increase the sum no matter where it gets added. Now the next pointer we shift is -1. So sum is equals to 4 plus -1 is equals to 3. Now we are not going to reset it still, okay? Yes, 3 is smaller than 4, but it's still better than negative, right? Because 3 will also try to increase the sum. 3 is a positive number, so you add it wherever, it will try to increase the sum. If you add it in the negative, yeah, it's a stupid thing. But if you try to add it to a positive, it will try to increase the sum, right? So we will still keep it. Then we will move the shift the pointer here. Now we have 2. So sum is equals to 3 plus 2 is equals to 5. Now, as you can see, that now it does make sense. Okay, it is making sense that, okay, we got a better number than 4, right? What we are trying to do is that we got a positive number, then we got a negative number, right? So we do want to remove the negative number, but we want to keep the positive number forward, right? We want to carry the forward. So we will eventually, carry this array forward. So that's how we got, 3 plus 2, 5 eventually. The pointer will shift to 1. Sum is equals to 5 plus 1 is equals to 6, right? It's a better sum. Remember, guys, at every time we sum it, we are actually doing this. Max is equals to, so each time the sum increases, the max also gets replaced. We shifted towards this one more time. We got -5, right? So sum is equals to, the previous sum was 6, then we add -5 is 1. We got this 1. We try to do this step again, and we do not replace the maximum till now because 1 is less than 6, right? So till now the maximum was 6, so we do not replace. But since it is 1, that is positive, we do not reset the sum to 0. We still carry everything till now. Okay, now we shift it here 4, and then we again do it 1 plus 4 is equals to 5, which is still less than the maximum that we got till now. So we do not replace the maximum. So maximum that we got till now is still stored in the max variable, that is 6, and we will simply return the 6. So that is an optimal solution, right? This is exactly what the Kadane algorithm is. So as you can see that all we have to do is iterate over each and every element once, right? So it is an order of n time complexity. Time complexity becomes order of n. And what about space complexity? Space complexity is still order of 1 because we are not creating any extra arrays in any of the solution. So all the solution that we saw till now, order of n cube, order of n square, and order of n, we have not been creating any extra array or any extra space, right? We are, yes, we are creating variables. Okay, but those variables will only take a constant amount of space, right? They are not some arrays that will depend on the number of input. They are going to be constant. Okay, so their space complexity is also going to be constant. Simple as that. So the space complexity is constant and the time complexity is finally order of n. Now here I have only coded the optimal solution because I already, wrote the code for all these n square and n cube right here, right now, right? So you can directly see it here. So I have just coded the optimal solution here. Now what I'm doing here is I'm taking an integer sum, and then I'm taking an integer max, and I'm initializing it with the minimum value that int data type can store. So this is the minimum value of int data type, and I'm storing it here. I'm initializing it like this. Now what I'm doing is that I'm iterating over each and every value in the nums array, and then we are trying to calculate the sum. So we simply add nums I in the sum, and we check if the current sum, that is this, is greater than this maximum till now, then we simply replace the max. In the next step we are actually seeing this. If the current sum is 0, sorry, if the current sum is less than 0, we are now resetting it. If it is not less than 0, we will keep carrying it. If it is 0 or if it is less than 0, we will simply reset it. And at the end of this loop, in the max variable, we will have our answer, and then we will return simply this max variable. And so let's try to submit this thing and we see how it works. So this is how you solve the maximum subarray Leetcode 53 with the help of Kadane's algorithm. Now, if you have some problem that you would like me to explain to you, then definitely comment. And now, bye.